Hello guys, so this video will basically demonstrate the use of change of origin and change of scale concept to find out the regression equation. Now suppose we have data set of this type. So we have a huge data set, huge in the sense we have 12 observations. So you have two variables as always, x, y. Suppose we have 43, 29, this is the first observation. 44, 31, this is the second observation. So I'm extending these row lines because I'll be needing these. 46, 19. 40, 18. 44, 19. 42, 27. 45, 27. 42, 29. 38, 41. 40, 30. 42, 26. 57, 10. So as you can see, there are 12 pairs of observations of x and y, and we have to calculate the regression equation. Now if you go by the first method, which is your OLS method, then so what all values, so for example, if we choose OLS method, then you need the values of x squared, you need the values of y squared, you need the values of xy. Okay, so suppose we take the observation 38, so 38 square will become a very large number. So we can't use OLS method. Obviously we can use, but it will be difficult to use OLS method in this case. So the next formula is your covariance formula. So for covariance formula, so your beta 2 hat is summation x minus x bar y minus y bar upon summation x minus x bar whole square. Now again, this formula can be used only if your x bar and y bar both are whole numbers. Now let us calculate what are our x bar and y bar in this case. So x bar, if you will calculate, it will come out to be 523 by 12, which is equal to 43.5833, so which is not a whole number. Similarly, y bar, if you calculate, it will come out to be 306 by 12, which is 25.5. So again, in this case, it is difficult to use this covariance formula, that is summation x minus x bar y minus y bar formula. So what formula we can use? So I told you yesterday, so in such cases we can use the fact that regression coefficients are independent of change of origin. So what do we mean by change of origin? So if we subtract a particular number a from the x series, and if we subtract a particular number b from the y series, then the regression coefficient beta 2 hat which is for y on x, is same as the regression coefficient beta 2 hat, which is v and u. Beta 2 hat, v and u. Now how do we choose u and v? So basically u and v, so how do we choose a and b? Basically a and b are chosen in such a way that they are closer to the mean. So for example, we can choose a to be 44 and b to be 26, because you can also take it to be 43 and 25, that is up to you, the answer won't change. So we have to calculate new series u and v. So how do we actually obtain the new series? So u is equals to x minus 44. Is this clear? Similarly, your v is equal to y minus 26. V is equals to y minus 26. So this first number becomes minus 1, second here becomes 3, then 0, 5, 2 minus 7, minus 4 minus 8, 0 minus 7, minus 2 1, 1 1, minus 2 3, minus 6 15, minus 4 4, minus 2 0, and 13 minus 16. So in this way you have calculated the new series u and v. Now what all other variables you need? So yesterday we discussed this formula. So based on the new series, beta 2 hat is given by n summation uv minus summation u summation v upon n summation u square minus summation u whole square. So basically you need the product of u and v, you need summation u, you need summation v, and you need u square. Is this clear? So basically, so the next two columns would be u, v and u square. Okay, so for example in this case uv would be minus 1 into 3, so this is minus 3, and u square would be 1. Similarly you will have 0 0, minus 14 4, (32 16), again 0 0, minus 2 4, (1 1), minus 6 4, minus 90 36, minus 16 16, 0 4, and minus 208 and 169. This is minus 208 and 169. So now if you calculate these values, so n is 12 because there are 12 observations, summation uv. So if you will sum the last or the second last column, the sum of this column comes out to be minus 306. The sum of this column comes out to be 255. So this becomes 12 minus 306 minus 5 minus 6. 12 255 minus 5 square. So this value comes out to be minus 1.22. So your beta 2 hat comes out to be minus 1.22. Now you can see, so for this data set, which was not easy to handle, we use this concept that regression coefficients are independent of change of origin, and we easily found out the value of beta 2 hat. Now beta 1 hat will be given by the same formula, which is y bar minus beta 2 hat x bar. So even though your y bar and x bar are fractions in this case, you'll have to use those values. So y bar is 25.5 minus 1.22, and x bar you can take 43.58. So you get as 78.67. I hope this is clear. So my final regression equation is yi hat is equal to 78.67 plus minus 1.22 xi. I hope this is clear. So this states that as the value of x increases by 1 unit, the value of y on an average falls by 1.22 units. So as we can see, we have easily done this numerical using the change of origin concept. I hope this is clear. So let me revise and let me summarize instead. So what all formula we have done till now. So there are basically, so this is the summary, and after this we will start the next topic. So summary, so there are 3 methods to calculate regression coefficients. So first is your OLS method, which involves basically solving the 2 least square normal equations. So what are the 2 least square normal equations? Summation yi is equals to n beta 1 hat plus beta 2 hat summation xi, and summation xi yi is equals to beta 1 hat summation xi plus beta 2 hat summation xi square. The second formula is beta 2 hat is equals to covariance xy upon variance of x. So which leads us to this formula, that it is equal to 1 by n summation x minus x bar y minus y bar upon 1 by n summation x minus x bar whole square. So these and this get cancelled out. If you further simplify this formula, you will get that this is also equal to n summation xy minus summation x summation y upon n summation x square minus summation x whole square. Now you can use the second formula, basically this formula can be conveniently used when your both x bar and y bar are whole numbers. Is this clear? But when x bar or y bar or both are fractions and not whole numbers, then we use beta 2 hat equals to n summation uv minus summation u summation b upon n summation u square minus summation u whole square, where u is a new series obtained by subtracting a constant a from that series, and v is another series obtained by subtracting a constant b from that series. I hope these formula are clear. Now I'll be giving one assignment which will involve the use of this formula to find out the regression coefficients. Now before we sign out, sign off, I actually found a very good rendition of our favorite school song Hum Honge Kamyab. So this is, I just wanted you all to hear this to lift up your spirits in this gloomy environment. So let me know if you guys like this